Silicon is a type of metalloid that is in the same group as carbon on the periodic table. It's not usually found on its own, but is commonly combined with oxygen as silicon, oxide and in metallic trioxosilicates, In fact, silicon is the second most common element in the Earth's crust. In this video we will look at some of the properties of silicon and its uses. Naturally occurring silicon compounds are mainly silicon, oxide and metallic trioxosilicates, Silicon, oxide, commonly known as silica, exists in its pure crystal form as quartz. It is also present in less pure forms such as flint, opal, hornstone, and jasper. Silica is a significant component of sand and kieselguhr, a porous material formed from the remains of small plant organisms known as diatoms. Metallic trioxosilicates, are found in slate, igneous rocks like granite and basalt, while clay and kaolin consist mainly of hydrated aluminum trioxosilicate, You can make amorphous silicon by heating a mix of pure dry sand and magnesium powder in a special clay pot. The process is quite intense, so it needs to be done with caution. Afterward, you add weak hydrochloric acid to get rid of any leftover magnesium and its compounds. What remains after this step is mostly silicon. To produce crystalline silicon, crushed coke, also known as carbon, and an extra amount of sand are heated in an electric furnace. The resulting product has a purity level of 98% and is suitable for crafting alloys. To make pure silicon, do any of the following. 1. Heat silicon tetrachloride with zinc. 2. Reduce trichlorosilane with hydrogen at a high temperature. Some of the physical properties of silicon include 1. Silicon is a solid that looks like a metal. 2. It doesn't dissolve in most common liquids. 3. Silicon has high melting and boiling point. 4. It can break easily because it's very brittle. 5. Silicon can conduct electricity sometimes, under certain conditions. Next, we will look at some chemical properties of silicon. When you heat silicon in the presence of air for a long time, it makes something called silicon, oxide, and this stuff is white and solid. Graphite does something similar, but you need to heat it even more than silicon. When you heat up silicon with steam, it breaks down and releases hydrogen. Silicon also mixes with chlorine in the same kind of heat to create something called silicon tetrachloride. On the other hand, graphite reacts with steam in a similar way, making hydrogen, but it doesn't react with chlorine. When you put silicon in hot concentrated solutions of sodium or potassium hydroxide, it dissolves and makes something called trioxosilicates, At the same time, it lets out hydrogen. Let us look at some of the uses of silicon. Silicon is added to bronze and steel to make them stronger. Really pure silicon is important for making things like semiconductors. These are a big deal in computers and electronics. With technology getting better, we can now make super complex circuits with over 1 million parts on a thin silicon chip. Lots of these circuits can be put together to make a microprocessor, the brain of small computers used in homes, schools, offices, and factories for various tasks, from games to controlling industrial machines. Silicon is also used to make silicones, which are like rubbery liquids or solids. They don't mix with water and don't react with chemicals. Silicones work as lubricants, water repellents, and electric insulators. They are also used in things like paints, varnishes, and polishes. Thank you all for joining me today as we delved into the fascinating world of silicon. From its fundamental properties to its myriad of applications in technology and beyond, it's clear that silicon plays a crucial role in shaping our modern world. If you enjoyed this exploration, don't forget to give it a thumbs up, subscribe for more engaging content, and hit that notification bell to stay updated on all things science and technology. Feel free to share your thoughts, questions, or suggestions in the comments below. Until next time, keep exploring the wonders of the elements and stay curious.